This is section 9-7. In this section, we're going to talk about facies, or metamorphic facies. And metamorphic facies are just the relationship between minerals, mineral assemblages, and metamorphic grade. So mineral assemblages are just when you have a group of minerals found together. So the relationship between mineral assemblages and metamorphic grade. So looking at the different mineral assemblages and different index minerals, you can determine the metamorphic grade. So the nature of facies depends on the geothermal gradient of the setting. So the temperature and pressure of that particular setting, the tectonic setting. Mineralogy depends on the protolith. So we're going to go over several different names, the different facies and their pathways, but so they all have the same name as long as they take that pathway, but like a hornfels may have different mineralogy depending on its protolith. So, draw a little graph here. So once again, increasing temperature, increasing pressure. So pressure is going to increase this way, temperature is going to increase that way. So up here, we're going to have the zeolite facies. Excuse me. Zeolite facies is due to shallow burial. So it is low temperature and pressure. And so we're going to go through contact metamorphism first. So that's just going to increase temperature without increasing pressure. So we're just going to run it along the top. This is going to be the hornfels. So this would be contact metamorphism. So the pathway for contact metamorphism would go from a zeolite to a hornfels. So hornfels is increase temperature, but low pressure. So you're going to get no foliation. The next one we're going to talk about is volcanic arc, and there's several different processes through here. Let's see. So the first one you're going to stop at is green schist. Green schist which is one word, is still fairly low temps and pressure, but it's greater than the zeolite. Then you're going to increase your temperature and pressure and go to your amphibolite. These are high temps and pressure. High temp pressure, maybe foliated. Sometimes amphibolites are not foliated. It just depends. Really, I should say green schist is more of a, it's not low, more of a medium. We'll put medium there. And then finally, granulite. Is very high temps and pressures. So we actually have two metamorphic pathways that run through these. And so I draw two arrows. First one would be volcanic arc. So remember, you still are at a convergent plate boundary, so you are still getting pressure. So this could be a volcanic island arc or just a volcanic arc. And then we have orogenesis, which is mountain building. That's going to be a little bit more pressure because it's more directed pressure, so that's why it's at the lower pressure side. Then we have burial metamorphism, which is going to go through green schist, a little bit of amphibolite, and then kind of just drop off. And it actually ends up in melting. And so this is burial metamorphism. Then we're going to talk about higher pressure, lower temperature. So down here we're going to have blue schist. Low temperature and high pressure. In this case, the rocks are, this is usually occurs in an accretionary prism. So they're getting compacted versus undergoing heat. And then at the bottom here, eclogite. So eventually this will go to eclogite. So it goes straight, go straight down through blue schist and into eclogite. So eclogite is medium temperatures and very high pressures. And so this is the accretionary prism, because it's being scraped and squished. In these two cases, what happens, the reason why pressure increases so much faster, basically they're being buried faster than they can heat up. So because rocks are poor conductors of heat, they're being buried at a faster rate, so the pressure is increasing at a much greater rate than the temperature is. Okay. So if we look at a convergent plate boundary, here's ocean to continental convergent plate boundary. So this is hydrothermal fluids, zeolite facies, and green schist facies form here because you're heating things up. But also it's just shallow burial. Over here you have zeolite facies because the sediment is being buried, so it's only going to undergo very minor compaction. So the accretionary prism right here is also going to have zeolites, but as you're subducting, because you're subducting this, you're putting it under extreme pressures faster than it can heat up, so you get blue schist and eclogite depending on how far it goes. Down here at the base of the crustal root, down here from the mountain building, that's where you're going to get your granulite and amphibolite facies under extreme pressures and temperatures. Up here you have your rising volcanics, so you're going to get your contact metamorphism, your Hornfels facies. You're also going to get regional metamorphism due to the compression, the green schist, amphibolite, and granulite, and then over here, deep burial, green schist, amphibolite, and eclogite, just depending on how deeply it is buried. So this is actually an excellent essay question, sketching question, where you would have to sketch this out and discuss the different facies and where they're found and why. Over here, I forgot to mention the hotspot volcanism. You do get Hornfels facies due to the contact metamorphism of the rising magma.